All right. Hello, everybody. Welcome to the last talk of Carleton Dev Day 2022. So I'm happy to introduce Matt back to the stage. Matt's the VP Academic of the Carleton Computer Science Society, a fourth-year student here at Carleton, and we're going to be learning about Kafka in this talk. So hello again, Matt. I'll leave it to you.
Hello, everybody. Welcome to the final talk of the day. Today, I'm going to be, my last talk of the day, or the last talk of the day, will be my talk on Kafka and event-driven architecture. So let's jump right into it. So yeah, a little bit about me. I've already done an introduction in my previous talk, but I'm a fourth-year student here at Carleton. And relative to this talk, at least in my last talk, I kind of talked a little bit about my knowledge of front-end stuff, as my other talk was about more of a front-end type tech area. But now I'm going to be talking about Kafka. And I have to admit, in the grand scheme of things, I'm relatively new to Kafka. It's one that I've been learning a lot about recently, and I'll talk a bit about that. But in the grand scheme of things, the goal of the talk I'm going to be talking about today is really not to make you Kafka experts. It's really to help you understand what Kafka is. So a little bit about my background with Kafka. I'm currently interning with Shopify on a part of Shopify called Shopify Flow. Shopify Flow lets you automate job like tasks and workflows within your store that automatically can do things like send emails, update product information, etc., but they can be scheduled, or they can be built in such a way that you can sort of like queue them in the background and stuff like that. You essentially can build workflows, as you can see in this screenshot. And because I've been working on this project, I've been working with quite a lot of Kafka, or learning about Kafka essentially since I started working there. And I've always kind of wanted to know what Kafka was, but I struggled for a really long time. It's like one of these like words that's out there, like it's just one of those pieces of tech that people, I don't know, say is important. Like I'm very interested in distributed systems and learning more about patterns around like how to build like horizontal like systems that can scale really well, or systems that are maintainable in the now that people are starting to care more about like microservices and all that stuff. And everybody talks about Kafka, and I didn't understand like why or how Kafka was special. And the goal of the talk today is solely to try and answer that question. I'm really not going to be like actually defining or like trying to answer really define the terms that Kafka already defines. I'm really just going to be trying to explain the context around like what Kafka is and like why you should care about it and all that stuff. So what is Kafka? Okay, like, and this definition that I've written here, this is probably not a real definition. It's not a perfect definition, but this is at least how I think of it. For the sake of my own brain, if you go and Google Kafka, you can you can Google some stuff about Kafka, and you're gonna find something that's really hard to understand. You're gonna see all this stuff about like it's a streaming platform, or that's a message bus, and you're gonna see all these different things. And it sounds like it would be something easy that you can just do your own research to figure out, but I don't know. I just had a tough time, and the sentence on the screen is the one that I've sort of come to for to best understand it myself. And that sentence is that Kafka is an ordered message log that also persists messages, with a very like big underline on the order part, because the idea of the messages that Kafka keeps being in order is like paramount to the reason why it's kind of important. And one of the reasons why, from what I understand, it's different than some of the other pieces of tech that might be comparable to Kafka in some way, like RabbitMQ and using like Redis as a like some kind of message like background job queue or something like that. But we'll talk about that in a little bit. But do keep in mind this order thing. I'm going to come back to that. But the order of the messages in Kafka matters. That's like one of the big parts of it. So in order to really give the context as to why something like this even matters, we really have to talk about like software as a whole, like different what things an application needs to do and why we need Kafka in the first place. And it's going to take a bit to get to the point where I'm actually talking about like why we need Kafka, or like why Kafka is useful. But in order to get there, I'm going to talk about some of the context. So in software, there are basically two kinds of tasks. There are tasks that need a real-time response, and there are other types of tasks that don't need a real-time response, or ones that can be scheduled. That's sort of like how I differentiate them. Things that need a real-time response, that could be something like Facebook, right? When you go to Facebook, you expect all the posts to be there. You know what I mean? You expect all that stuff to already to be there within like a couple seconds, something like that, right? That can be sort of done. That should be done very quickly, instant for you. You know what I mean? However, something more like sending an email, right? You've probably sent an email to yourself at some point in your life, and you've realized that it's not instant, right? Like there's some level of like time it takes between those email sending, right? And because the person who sends the email doesn't really get anything back other than the fact that it says they've sent the email. They don't need this like instant gratification. The other person, the other end of the email, can wait as long as it takes for the application that's sending that email to have, either the resources or the, I don't know, the computational like availability to actually send that email. So there's some tasks that, for example, like sending an email that essentially don't need to be instant and can be scheduled. Within the category of tasks that don't have to be instant, there's also a few different kinds. So there's a differentiation between things that are then scheduled and things that are just units of work that don't need to be instant. And the two terms, and these, I guess I said I wasn't going to define terms, but these are sort of important terms, is number one, background jobs, which background jobs are essentially when you queue a unit of work that can be done later, but you don't have the availability for right now. And then cron jobs, which are separate. Cron jobs are specifically, or like, are a way of defining tasks that can be scheduled. The cron being like cron. I'm sure it has some derivation from like chronology or like whatever. I know cron has some kind of connection to the word time. And essentially you would use either of these tasks, when you do need something that takes a long time, but there is a separation between the two, and that matters for some of the stuff we're going to be talking about with Kafka. So within, again, I said I wasn't going to define terms, but we're going to define a bunch of terms. But within this system, or within, when we start thinking about having these background jobs, these cron jobs, all this stuff, right? This starts to affect the way that our application is built. We have to start thinking of saving these, like, how do we persist this? How do we know when we should be executing these things? And usually we refer to these things as messages. Okay, so when I'm talking about like when people talk about like message buses or message queues or message logs or all of that stuff, they're usually referring to a structure of some kind. I'm not saying, I'm making this as vague as possible. Basically, a structure, whether that be a queue, whether that be a log, whether it be like a message bus, whatever you want to call it, right? Basically, a place where we can store messages, and those messages can represent the background jobs we need to do. So, like when we want to send that email, instead of making the user sit and having us do like some kind of like a wait, or being like, hey, let's wait till the email sends, right, and then tell the user it sent or something like that. Instead, we essentially put a message on some kind of background, like some kind of queue, some kind of message. One of the three different words I use, because they all have different meanings, I'm trying to be as vague as possible. We essentially publish a message that says, hey, we want to send that email. Okay. And because we put it onto that queue, it means that it can be consumed once there is, nothing else on that queue, or we eventually get to the place on the queue where that message has risen to be the message that will be sent next. So the other word on here I see is we have the word message queue. So essentially, let's say we were sending emails, we probably want to send the email that we probably want to do them in order, right? So even though we might not do it instantly, we should at least probably like take into account that we should do the emails like in order, right? And queues usually are in order. Now, obviously, they're priority queues, and some of the structures on here, things like RabbitMQ and Redis, some of them do support. I believe at least RabbitMQ supports having priority queues when it comes to putting messages on a message bus. But essentially, what you do is when you are sending that email, you put a message saying, hey, please send this email onto the message bus, where later on that message can, when there is availability to then conduct that unit of work, popped off the queue and consumed by some other application that will fire that email, or the same application, who knows, right? But yeah, that's the general gist of it. And as I mentioned, I sort of use these words publish and subscribe. Some people will be familiar with the idea of like pub sub, or like the pub sub pattern. Basically, in reference to what I'm talking about here, when we are putting these messages onto this queue, we are essentially, in that case, if you start to think about pushing messages onto some kind of queue, you can then think of that entity that is pushing as a producer, as it is producing messages that represent those units of work. Whereas the application that will eventually like send the email in our use case will be the consumer, right? Or the in this case, the subscriber. It will be listening for emails to be sent, and when an email becomes available that needs to be sent, it will consume that message and send the email for you, which is a big part of the general paradigm that Kafka works in. However, as I mentioned before, the order of messages kind of matters, okay? And that's what makes Kafka kind of different. Um, the other thing that makes kind of Kafka a little bit different is the idea that it persists messages. But from what I understand, you actually can make Redis persist messages, and you can make RabbitMQ persist things. However, RabbitMQ doesn't keep an order of the messages that get passed into its queue, which is a really big deal. That's sort of detrimental to the use case that I'm going to be talking about when we're talking about Kafka. But essentially, RabbitMQ, Redis, those are usually commonly used for like I don't know. I build like a lot of Rails apps. Like when you work with like Sidekick, which is a background job queue, we work with Redis, and I've used RabbitMQ for other task management type things. Basically, neither of them order messages, and that's they're great for sending things like emails, but the use case or the like event driven architecture use case I'm about to talk about requires you to have ordered messages in order to take advantage of the benefits I'm about to talk about. So why do we care about the message order, right? Like that's what I keep going on about, right? So it all comes back to how event-driven architecture kind of works. So in order to really understand that, though, I'm going to give you a use case of an app where we aren't taking advantage of like event-driven architecture. We're just doing what we would sort of normally expect to do. So in this use case, we have like some kind of like fictional item. It's just initially called new item with a price of 0, 0. And usually the way it would work is like as you update that item or as you like use your application, you'd like make operations on the database. You do something like update the name of the item, or you would update the price, or maybe you delete it, or maybe you'd create new items, etc., etc. And those operations would be applied directly to the database. And we would just have one, like that column or that space in the database would be updated every time, right? And that's fine. Okay, but that's great and all. However, the paradigm that Kafka thinks in is that of an event-driven paradigm, I guess. I don't know if paradigm is necessarily the right word, but it's sort of a difference in how you think about things. So in this case, you can think of the item as like an entity. But in the new case I'm going to show you, you can think of the entity as actually an aggregate of all the events that occurred to create that entity. So in order to get the final result of the apple with the price of 299, we could actually take the aggregate of all the events that occurred. So so the item being created, the name was updated, and the price was updated. If we took all those events and we applied them to the database, we could recreate the current state of the database. And this idea, and I'm going to show you why this is really important. This idea is really what makes Kafka really important, and I'm going to show you why in the sense of distributed systems in a second. But this is why the order of the log matters. So, in order for this to actually make sense, right? In order to make sure that the aggregate of your messages or of your events actually result in the proper state of your database, you need these messages to be in order. And this is, again, if they weren't in order, right, you might get something like, let's say, for example, the message for item created came after the name is updated, right? That would just break your application. Like there would be a problem there, right? So what would you do, right? It just wouldn't make sense. So making sure that everything is in order is very important. And obviously that's not to say there isn't a use case for like RabbitMQ having like priority queue on certain tasks, but we're not thinking in the case of like sending emails anymore. We're now thinking about how we can use events to conceptualize the data within our system, which is obviously that's a big jump from what I was talking about before with the email. But this is, again, I'm going to explain why that's like so important in a second. So the next thing we have to do, and again, I have to give you more context again to really help establish the understanding of why this is such a big deal in distributed systems, is there's a pretty big difference between monolithic and service-based apps. So if you haven't heard these terms before, like the monolithic versus microservices thing, essentially what a monolithic app is probably what you've done so far in like 246 or whatever other classes you might have taken that were more web development-y. I don't think I've ever taken a class in school that actually forces you to use like microservices, but essentially what it means is that you have one huge application that encapsulates all of your logic. So you probably have like one backend, maybe one client and a database or something like that. However, in recent times, it's become like increasingly popular for companies to start using a new pattern called microservices. And there's a lot of benefits to this. And essentially, what it is instead of having like one really big application, you have a bunch of tiny little applications that can all do different little parts of the application. Some of the benefits that are, I'm going to go over another slide, but I'll talk about that in a second. But basically, monolithic apps are all one big app. They're essentially easier to work with because there is one complete code base as opposed to a bunch of really small, tiny code bases. And because you're not like, if you can think about microservices, right? If you have two applications and those applications need to talk to each other, they're going to need to talk to each other over some kind of like protocol or something, right? Like when you're a client, you're like your React client sends some request to your Express backend in 2.4.6, right? There is a delay in that time, right? So instead of having that delay, if you're all in one code base, you don't have to deal with that, and that's a really big benefit. However, there are also benefits to having a microservice code base. Number one, the what you can do is you can actually scale up individual parts of your application. So let's say, for example, the example I always give people, and this is not like a real example because I don't actually know how Facebook is structured, but a lot of people know Facebook as there's like the Facebook part of Facebook with the profiles and all that stuff. And some people also know like Facebook Messenger, right? So conceptually in my head, I think of those as kind of like two separate applications in a sense. But let's just say as an example, right? Like a million people are using Messenger, but like no one's actually using the normal part of Facebook, right? You wouldn't want to have to like pay to have like the server capacity for people to be using both at either time, right? Instead, you really only want to have to pay for like people using Messenger, and like a more microservice based architecture, one where you can scale up individual services within your like general application, I guess, or within your system, right? Becomes a benefit. It's just that when you start breaking up an application to lots of little applications, you have to start thinking about how those applications are going to communicate with each other, where the data is going to be stored, and it becomes a lot more complicated very quickly. And I don't know if there's like hundreds of relatively speaking, microservices are kind of like a new thing. So there's still a lot of like investigation as to like what the best patterns are and stuff like that. But honestly, I don't know, find it really interesting. So I spent quite a lot of time looking into these patterns, and Kafka is one of the ways that we can solve communication within a very complicated microservice based architecture. Some other benefits of microservices I just wasn't even reading off my slide. I apparently wrote this on my slide is because you can write a bunch of individual applications. One of the other cool things you can do, right, is you can actually write all your different applications in the language that would benefit the use case of that single application. So, for example, I don't know, Facebook Messenger example, right? Let's say I was going to build something like that from scratch right now, and I was using microservices. Maybe it's better for me to build I don't know, like Messenger part of it in something like Elixir, a language that's built for like real time applications, as opposed to building it in something like, I don't know, Java. You know what I mean? I'd rather build the messaging application with something that is built for like real time communication. I'd rather build like maybe the business, like the actual Facebook part, and something that's more built to just handle like the general use case of like, I don't know, good response, like, I don't know, general business logic type stuff. You know what I mean? But that is one of the major benefits of like microservices. You can actually build every little microservice in your thing in a separate language, just have them communicate. This also it's also easier for teams to work, so teams can very quickly pick up like how to, like, because you don't have to really worry about the people around you. If you just know your service or the services that you're working on, and you don't have to worry about like all the services that are like reaching out to you, you just have to provide like an API for them. It becomes a lot easier to work with because you don't have to understand how the code of the other services you're not working with works, which in like larger like organizations can be a benefit. But yeah, those are some more benefits of using microservices. So how do services work with Kafka? So Kafka has this concept of topics. Um, Essentially, with as I mentioned before, with the ideas of having like consumer like publishers and consumers, or publishers and subscribers. Um, your services, your microservices, can individually consume and publish to different events that represent what they are doing. And Kafka has this concept of a topic. And topics essentially represent events that have happened, or when you publish them, like you can publish two specific topics to identify the kind of message a message is, so that other microservices within your system can then identify that they are, like, they can subscribe to a topic, so that when a certain event occurs within your system, they know that it's happened, and they can then perform the work they need to do when that has happened. So one thing that, or the benefit, I guess, to Kafka, relatively speaking, is this idea of like tight versus loose coupling. So in a normal application, right? Like I'm talking about Kafka, but and you could totally do microservices just with HTTP for fun, right? So let's just say, for example, you had some kind of system where you had two node apps, okay, just for fun, right? And you had this like React client or something. And one node app communicates with the database, but another node app is more of like a gateway API or something for whatever reason. Like this is a very simple example. Obviously, like this doesn't really make any like the most sense, but let's just go along with it for the fun of it. So the problem with this is that if one of these node apps dies, essentially the entire system will break, because if, for example, this one dies, even if the React client hits the gateway API and this gateway API sends a message to the second like data service, nothing is getting communicated to the database, which is a problem, right? Like you just have breaks in your thing, and we'd have to tell the client like, hey, this didn't go through, something like that. And this concept of like needing to be dependent on lots of other services it refers to the fact that this service, or the service that isn't dead, is tightly coupled to the one that is dead. Which isn't great. And as you can imagine, there are systems with thousands of microservices, so this pattern really doesn't work. And that is where Kafka comes in. That is where Kafka is like kind of the big deal or whatever. This is why Kafka is cool. Okay, so instead of directly hitting those services, instead what we can do is we can have our first service send a message to Kafka. And the reason why that's important is because if that service dies, the one that would have caused the break before, it doesn't matter, because it can later on, when it turns back on, then reconsume the messages from Kafka from when it was no longer gone. And as I mentioned before, if you think of all of the state in your application as just an aggregate of events, it doesn't necessarily matter if the database has the most up-to-date data right away. Like that's a huge problem, but I'm just saying relative to this example, right? Um, let's say that application did die for like just a second or something, right? Once it turns back on, it can then reconsume the operations that have happened on the client, and then the data in the database will theoretically be up to date, right? Now, there obviously is the problem of like, okay, well, what happens if someone requests the data before that operation goes down? And that is more of an issue of something we call propagation time, which is propagation time is basically like the latency between how these units of work like flow within your system, but that is like a completely different problem. But the main benefit to Kafka here in this use case is that we are essentially eliminating the, like, this is in this example, you can refer to this as like loose coupling. And that's because the service that we're hitting with our React client is no longer dependent on the service that was talking to our database. It is not tightly coupled to that service anymore. So it does not matter whether that service dies or not, or if it is online or not, which is a benefit to us. And I think this next slide. I have a slide that says resilient. So yes, this makes your system more resilient, just because your system is less prone to fail from a single point of failure, or from, I don't know, a single service dying or something like that. But as you can imagine, as applications grow in size, right, like you could have a system that looks more like this, where there are tons of services constantly talking to each other. And if they're all tightly coupled like that, if a single one of those dies, right, it brings all of them down, which is not great. So instead, if you have all of these services instead talking to Kafka, um, instead they're all sort of, they are in a sense like tightly coupled to Kafka. However, assuming that Kafka is going to die is the same thing as assuming your like Postgres database is going to die, right? Like Kafka is essentially a database for events, for these messages that we've been talking about. And to assume that Kafka wouldn't be online is kind of to assume that like something like Postgres would just be dead. So it's way less likely that like Kafka is going to be dead than something like one of your little Node.js services. You know what I mean? So it's much more reliable to use something like this than to have all of your applications like coupled over like whatever protocol you want to use, whether it be like gRPC, HTTP, all that stuff, right? Instead, if we have all the services talk to Kafka instead, what this leads to is Kafka can then act as this like essentially source of truth for all events in our data in our system, right? Because if, for example, you reset all of the databases that every single service had, right, just for fun, and you took just all of the events that were stored in Kafka and played them out, and all of the services within your system consumed those messages and did the operations they need to do from the message that were left in Kafka because those messages are persisted in order, you would actually theoretically rebuild the current application state. So it's actually in many ways just it's a different way of thinking about it. Like, obviously you have to think about it in terms of events now instead of these like database operations, but it's actually in many ways it just feels better in some sense, because it just feels like you're actually you're saving a record of all the individual events that occurred in your system in some way. At least that's how it feels to me, which is really cool. But yeah, that is the general gist of what Kafka is. Okay. I know that wasn't super long. I know I didn't get into the nitty gritty of a lot of the things about Kafka, but my main goal with this was literally just to talk about like what it is. And the basic idea of what it is to reiterate, it is essentially I want to use the exact words I use so that I don't accidentally screw something up. But it is essentially an ordered message log that also persists messages. And this is really great. And the reason why everybody talks about it in distributed systems is because it's making the management of microservices significantly easier, because it is allowing us to build microservice-based systems that are decoupled and can work sort of, in their own ways. And as I don't know, for whatever reason, microservices are super popular right now, for all the reasons I mentioned. And Kafka is one of the technologies that is just making it easier to work with microservices, which is really great. This doesn't mean you can't use Kafka for like some of the other stuff I said, like sending emails and stuff like that. But because there are a bunch of different like kinds of logs. So for example, I've mentioned RabbitMQ a few times. I know, for example, like RabbitMQ has like the feature of like prioritizing messages on it, right? Which would be great maybe for like if you have other units of work. Maybe some emails are higher priority than others, like transactions are higher priority than emails or something. Like, I don't know what kinds of units of work you might be doing, but we're thinking about Kafka not relative to those kinds of units of work now. We're thinking of it in terms of like relative to operations. And that's not to say you can't do it with those operations with Kafka, but the reason why Kafka is really powerful in the sense of just working distributed systems is for the general passing of messages within your like service architecture. Or at least that's how I see it. Obviously, again, as I mentioned, I'm very new to Kafka. It's just something that I think is really cool and something that I was really struggling to learn for a long time. So I want to share it with everybody. But yeah, I hope that you guys enjoyed that presentation. Hopefully, it made sense. Yeah, thank you for attending, and thank you for coming to Dev Day. I know that this is like the last talk, so hopefully you guys all enjoyed all the talks today. And yeah, I'm going to end off the stream. So thank you.